Okay, let's get right into it. We're talking about gRPC today. You might have heard of it, but what is it really? Well, think of it as a supercharged way for computer systems to talk to each other. It's a high-performance framework born out of Google that's really shaking up how we build modern distributed applications. The whole point is to be fast, super efficient, and work absolutely anywhere.
So we all build with APIs, right? If you're a developer, it's just part of the job. But let's be real. You've probably felt that pain, that friction, when you're trying to integrate them. There's this hidden complexity that just eats up our time and, honestly, creates a ton of risk. So what is that hidden problem?
Well, it really boils down to this one thing, the API client problem. This isn't just a small annoyance. It's the core issue, the very reason gRPC was even created.
So what is the client library problem exactly? Let's break it down. Think about any service you've ever built. It could be a standard REST API spitting out JSON, or maybe even an old-school SOAP service with XML. For any other application to talk to your service, it needs a special piece of code, a client library, that basically acts as a translator. Now, if you're building for the web, life is easy, right? The browser is your client library. It handles all that complexity for you. But what happens when you're not in a browser? That's where things get messy.
And that's where the real headache begins. Suddenly, you need a client library for Python, another one for Go, another for Java, the list goes on. And guess what? Someone has to write and maintain all of them. Now this is the scary part. Imagine the person who wrote your C# client library just disappears. They move on to another project or quit. Now you're stuck. You literally can't upgrade your server to something modern like HTTP/2. And worse, if a security vulnerability pops up, well, good luck. There's nobody there to patch it. It becomes this huge, risky burden that you, the developer, have to manage.
This is the exact chaos that led to gRPC. Google looked at this situation and basically said, no way, this is unsustainable. They realized there had to be a better way, a more standardized approach to solve this mess once and for all.
So the thinking was, we're going to unify the client libraries, we will build gRPC for you guys, there's a bug, we're going to fix it for you. The idea itself is so simple, but it's incredibly powerful. Instead of dozens of random community-built libraries, Google and the open source community would create one official, high-quality, maintained client library for every major language. The takeaway? You don't have to worry about it anymore. It's just like your web browser. There's a whole team of people whose job it is to make sure it's up-to-date, secure, and just works.
Okay, so how does gRPC actually make this happen? What's the magic sauce? Well, it's really built on two core ingredients that fit together perfectly. Let's dig in.
All right, so gRPC has two main building blocks. First, you've got something called protocol buffers, or Protobuf for short. Think of this as the contract. It's how you define what your service can do and what the data looks like. Then you have HTTP/2. This is the transport. It's the super fast highway your data travels on. And the reason HTTP/2 is so quick is because of cool features like multiplexing, which lets you send a whole bunch of requests over a single connection without them tripping over each other, and really smart header compression that just cuts down on all the extra baggage.
This really highlights the huge difference between Protobuf and what you're probably used to, which is JSON. JSON is text, right? It's human-readable, it's flexible. Protobuf is completely different. It's a binary format, and it has a very strict, predefined structure or schema. Now, why would you want that? Because it makes the data payload incredibly small and way faster for computers to read and write. So yeah, you give up a little of that free-for-all flexibility you get with JSON, but what you get in return is a massive boost in speed and reliability.
So what does the actual workflow look like? It's surprisingly simple, really just 3 steps. First, you define everything, your services, your messages, in a special file called a .proto file. This becomes your single source of truth. Step 2, you run a special compiler on that file, and poof, it automatically generates all the boring client and server code for you in whatever language you want. Then, step 3, all you have to do is implement your actual business logic on the server. You get to focus on the fun stuff that makes your app special, not the plumbing.
Okay, now this is where gRPC gets really cool. It's not just stuck in the old request-response world like a lot of APIs. It actually supports 4 different ways for services to communicate, which gives you a ridiculous amount of power and flexibility.
First up is the classic, unary RPC. If you've ever used a REST API, you already know this one. It's the standard request-response model. The client sends a single request, and it gets a single response back. Simple, straightforward, gets the job done.
But then we have server streaming. This is where the client sends just one request, but the server can send back a whole stream of messages over time. The best way to think about this is watching a video online. You make one request to load the page, and then the server just keeps sending you chunks of video data. That's server streaming. And you can flip that right around with client streaming. In this case, the client sends a stream of messages, and the server listens, collects them all, and then sends back just one response at the very end. This is absolutely perfect for something like uploading a big file, right? You send it up piece by piece, and when it's all done, you get that one, "Okay, we got it" message.
And finally, the most powerful one of all, bidirectional streaming, or BIDI streaming for short. Here, both the client and the server can send streams of messages to each other at the same time, totally independently, all over the same connection. It's like two separate conversations happening at once. The go-to example here? A real-time chat app. You're sending messages, your friend is sending messages, and it all just flows back and forth.
All right, so that's the tech. We've seen how it works under the hood. But let's bring this back to the real world. Where does gRPC actually make sense to use?
Look, no technology is perfect, and it's all about trade-offs. The pros for gRPC are massive, right? You get incredible performance, you solve that whole client library nightmare we talked about, and you get these advanced streaming capabilities. But there's a flip side. That strict schema can feel a bit like a straitjacket if you're coming from the loosey-goosey world of JSON. It also doesn't work in a web browser out of the box. You need a little helper for that. And yeah, trying to debug a stream of binary data can be a whole lot trickier than just looking at plain old text.
But don't just take my word for it. gRPC isn't some niche experimental thing. It's a full-fledged project in the Cloud Native Computing Foundation. That's the same home as giants like Kubernetes. And look who's using it in production every single day. Google, of course, but also Netflix, Square, Cisco, Docker. These companies are running massive global systems, and they trust gRPC for that critical, high-speed communication between all their different microservices.
So here's the bottom line. The most important thing to remember. gRPC is not a REST killer. It's not here to replace REST for every single thing we do. REST is still fantastic for public APIs, for things that need to be easily understood and used by a browser. Where gRPC really truly shines is for internal communication, for those high-traffic, performance-critical connections between your own microservices. It's a different tool for a different job. So the real question isn't which one is better. The real question is, which job are you doing?